John Dalton in 1808 helped us understand more about atoms, and he put forward the Dalton's atomic theory. This Dalton atomic theory over the years have undergone several changes and modifications because some of the statements through experiments have been proven to be wrong or cannot hold completely. So now we're going to look at the statements of the Dalton atomic theory, and at the same time I'll be mentioning or pointing out the modification or the modifications that have been done on these statements. So let's look at the first statement of Dalton's atomic theory. All elements are made up of small, indivisible particles called atoms. Is this true? Yes, because all elements are actually made up of atoms, small atoms, but that these atoms are indivisible. Now, through the experiments of people like Rutherford, we're able to know that atoms are actually divisible. Atoms are actually made up of protons, neutrons, and electrons. So whereas the first part is true, the second part is not true. So this used to be very correct, but because of several experiments that have gone through in recent times, we are able to find out that atoms are actually divisible. Number two, atoms can neither be created nor destroyed. This still holds true for ordinary chemical reactions, but we know that in nuclear reactions, things like uranium can still be broken down into other atoms of other elements. Now, so this one, nuclear reactions, makes this very statement to be not completely true. Here the discovery of electrons, protons, and neutrons made this not to be completely correct. So these are the modifications to this, whereas nuclear reactions should be taken into consideration for you to have this to be true. Now, thirdly, we have that atoms of the same element are alike in every aspect and differ from atoms of all other elements. This is not completely true because of the discovery of isotopes. Now, in isotopes, we find out that one element, say chlorine, can have different isotopes. They can have the same chemical property, but the mass number will not be the same. So this is the modification to this. Now, when atoms combine with other atoms, they do so in simple ratio. This is actually correct for inorganic reactions. The combination between the combining atoms, different atoms, for inorganic reaction can occur in simple ratios. But when you have complex organic reactions, like that involving proteins or other things in organic chemistry, there is no simple ratio combination. You can have them in multiple ratios. Now we have the fifth statement of the Dalton atomic theory. All chemical changes result from the combination or separation of atoms. I think this still holds true. So these are the statements of the Dalton's atomic theory, and these are their modifications. So these modifications were born out of experiments that had been conducted since after Dalton in 1808. Since after John Dalton in 1808 put forward the following statements. Much of this statement has already been supported by things like the law of multiple proportion, the law of conservation of mass and other laws. So in subsequent classes, we are going to be using those laws to do a lot of calculation and other inferences. Thank you.